So now we have the circuit right here. What we did is take this negative charged cable to the negative side of the second battery, and then tape this positive charged cable to the positive charge of the other battery, and then the cables coming from this battery, we screwed it to this bulb right here, and then this negative, we screwed it to the other side of this other bulb here, and my thing is a little unstable, excuse me, so there we go. So, and then we connected this yellow cable, connecting the negative side of the bulb with the positive side of the second bulb, and now what we're going to do is unscrew one of the bulbs. So we're going to unscrew the first one. So by taking the bulb out, we can see that the light is not turning on anymore, and this is due because bulbs are set up in series, which means that there's only one path for the current to flow through the bulbs, and by removing one of the bulbs, what we're doing is opening the circuit, which means that the current doesn't have a path to go to. Therefore, we don't have this second light bulb will not turn on. And the expected value for voltage on this second bulb is going to be 0 since there's no current flowing through it. So now what we're going to do is wire the circuits having the batteries in series and the bulbs in parallel. Okay, so now we have our circuit with the parallel bulbs and our batteries in series, and we can already see that it's a lot brighter than on the first experiment, and this is because now we're doubling the voltage. So the next step is unscrewing one of the bulbs. We take it out, and we can see that in this case the other bulb is still on, and this is because now the current has another path to take in order to complete the circuit. So we're not going to have any current going through here, but we do have current going through this red wire and this yellow wire connecting to the first bulb. Let me put it back in, and they're both working. So now we're gonna measure the voltage drop on one of the light bulbs. So we're gonna put it at our highest just to don't burn any fuel, any fuses. And oops. And so this is 1.4, so I'm gonna lower it to 20 just to be more precise. And now this is 1.41. And then I'm gonna lower it to 2. And now I'm gonna set it to 2, and we're gonna measure it one more time. And this is 1.417. And we cannot go lower than that. So now for procedure 4, we're just going to wire one lamp to one of the batteries. So let's go ahead and unscrew some of this stuff. So we don't need this anymore. And then this over here. I'm just going to do this one. So here we have just one battery. These cables are not connected, and to one of the bulbs. So now we're going to go ahead and measure the current of our circuit. So for that, it is important to have our circuit in series. So we're just going to disconnect one of the cables and place this two on each side of our circuit. So one on the battery and the other one on the other end of the lamp. And we need to make sure before we do any of that that we have our DMM in the correct settings. So we're just gonna, since we don't have what the current in here is, we're just gonna put it up to the maximum current which in this case is gonna be 10 amps. So we're just gonna change the input for this red cable to the one that has a 10 amp sign in there. And we're also gonna change our dial up to the 10 amp one before we measure anything. So we always want to start with the maximum. And then after that, we're just gonna go ahead and place one part. Let me actually turn this off so that you guys can see the light. We're gonna place the red one on this side. And we're going to place the other end on the battery, and we can see how our light is turning on, and we're actually measuring a current of 0.24. So now we're going to measure the resistance of the bulb, so we need to take it out of the circuit, and then what we're going to do is set up our DMM to measure resistance. I'm going to start where it says 2 million ohms, and then we'll see if we can get lower than that. We're going to put one of them on the, I don't know if you guys can see it, but one of them on the metal part, and then the other one on the tip, and it says 0, so we're going to go lower than that, probably to 20K. And then we're going to go a little bit even lower than that. So we're getting a value of about 1.2 ohms of resistance.